Alrighty, so we're going to be talking about objects and object-oriented programming in Python. Kind of an overview of what this is going to go over is we're going to kind of go over what the heck is an object and the concept of object-oriented programming, differentiate between the different parts of an object, which are its attributes and its methods, learn how to create objects from sort of the definition of what those objects should look like, and then also apply object-oriented programming or object-oriented thinking to real world, real life situations. So what the heck is the main idea behind object-oriented programming? The idea is kind of the basic idea is not everything in life is simple. And so when you have more complicated use cases, when you have more complicated situations, you can't always necessarily represent everything using something simple, something straightforward like we've been doing so far. Things like ints, strings, and lists. Those are perfectly good for those straightforward kind of like single value type things. But when you come to more complex ideas or bits of data, then that gets a little bit more complicated. So not every situation can be represented by a string. Not every situation can be represented by an int or boolean. And so sometimes you might need to create your own different type of variable or different type of value to represent those more complicated things. And so that's where object-oriented programming comes in. Object-oriented programming is a way of thinking of organizing code or organizing sort of like ideas of this is what something should look like, and thinking of all of those things as objects that interact with each other. So this is a bit more of a slightly more modern methodology of thinking about how to design software, in which the basic building block is something called an object or a software object. And so Python is a language that allows you to be object-oriented. So things that we've been working with so far, lists, strings, and dictionaries, we've seen that they have extra capabilities beyond just holding single value. Those are all objects. They are made of a couple different attributes or variables or values, and they have built-in behaviors or methods that we are able to use kind of right off the bat. And so that's kind of part of the characteristic of the object. It's kind of being like, here's a slightly more complicated use case, or here's a slightly more complicated bit of data or bits of data that we want to store. And so we need to have a new structure to store all of that. And that's where objects come in. And so object-oriented programming lets you represent real life objects as sort of bits of code or objects in code. So they can represent like actual physical things, like people, houses, cars, things like that. They can also represent abstract ideas like color, words, shapes, your job. And like those real life objects, whether or not you can actually like touch them and see them, or whether or not they're just abstract ideas. The idea of an object combines the idea of something has characteristics or attributes, and that thing also has behaviors and methods. And so an object kind of takes both of those two, well, characteristics, both the characteristics and the behaviors, and sort of wraps them together in this one thing and says, hey, this thing has these characteristics and these behaviors at the same time. And so it's kind of all packaged together. So if you want to think of it from kind of this like real life perspective, think about a vehicle. Think about like, I was going to say car, but a car is kind of vehicle. Think about a vehicle, something that you can drive, something that takes you places. So what attributes does a vehicle have? If you were to just describe a vehicle to someone else, how would you describe it? And what behaviors can a vehicle perform? What can you do with a vehicle? So actions a vehicle can do, so something like driving forward, reversing, parking, things like that. And so those are kind of like two different categories of here's how it can describe sort of what defines this is a vehicle. Like if you stare at something and you kind of have a checklist of, is this a vehicle? That's what these two things kind of contain. So the attributes would be things like number of wheels, like what's the color, what's the make, what year was it made in, things like that. And behaviors would be like turn right, turn left, it has AC, doesn't have AC, speed up, slow down, honk your horn, although don't do that often because people can get aggressive, but those are sort of the two different categories of things that define a vehicle. Or if you can check off all those boxes, you can say this for sure is a vehicle. So one example of something that matches those criteria would be something like this B-shaped car, kind of over here. It has a bunch of wheels. It presumably goes at a certain speed, has a license plate somewhere on this vehicle, and things like that. And so it can speed up, slow down. You can fill up the tank because you need to fuel it. So because it has those characteristics and you can perform certain actions with this vehicle or with this thing, you know that it's a vehicle. On a similar note, we can also look at this shoe-shaped vehicle. It has a certain number of wheels, has a license plate, can hold a certain amount of gas. You can do certain things with it, so you can accelerate, decelerate, fill the tank. And more examples of different kinds of vehicles. They all look different from the outside, but each of them have the same basic traits. So like they all have wheels, they all have some kind of fuel source, they can all speed up, slow down, and things like that. And so once you can establish kind of a basic list of like common characteristics that make something, that define something as a vehicle, you can kind of start to figure out, if I was to represent a vehicle, what would I need to know about it? How would I define this as a vehicle? And so that kind of brings us to the idea of defining and creating objects. And so objects are created from, there's sort of two parts to having an object. There's sort of laying out the requirements to create the object. So that's defining what it should look like. And then there's also the actual like creation of an object to say like, okay, based on my definition of what an object should look like, if I set up something with these particular characteristics, I now have this object. And so the definition of what an object should look like is called a class. So that class is sort of like, we'll get into what that is in a hot sec, but the TLDR is a class is a set of characteristics to say this is what makes up an object, and also behaviors or actions that you can do with or do on the object of like, these are its capabilities. So those two put together, and by listing all those things put together, that's what the class definition is. An object is when you say, I'm going to take that list of requirements, take that list of characteristics, take that list of actions, and go create something based off of that. That's what an object is. And so you can have a single class definition and create several objects from that definition. So if we go back to the car analogy, it's kind of like saying, here are the instructions for how to make a particular kind of car. You only have to create those instructions once, assuming you did it properly. You only have to create those instructions once, but you can make many cars off the same set of instructions. And so it's kind of like that idea of set of instructions, the things you make with the instructions. That's kind of the two sections of sort of defining and then creating objects. So classes, again, are like blueprints or instructions or directions. It is not an object itself. You can kind of think of it as a piece of paper with a set of instructions on it to create something like, say, a teddy bear. It's not the actual teddy bear, it's the instructions on how to create the teddy bear. And so these are like actual chunks of code that kind of list out those characteristics and things like that, and methods that make up that class. You can kind of also think of a class as a cookie cutter to kind of be like, this is how I'm going to define what I'm going to make. So if you wanted to say like make an animal shaped cookie, you can kind of think of it as the class being sort of a set of instructions or a cookie cutter to say like, this is, man, that was off. This is what my cookie should look like, or this is how I'm going to determine what my cookie should look like. So you can kind of think of the class or the cookie cutter with a set of instructions. That's what the class definition is. And then the instance is the things that you make with that cookie cutter or set of directions. So if the cookie cutter is saying that all my cookies are going to kind of look generally in this shape, or I'm going to use this to create my cookies. So that's the class. And then we have instance, which is the actual cookies that you made with those set of instructions. So that's sort of a very horrific drawing of the two, the difference between the two. class is the instructions, the cookie cutter, or the definition. Instance is the actual objects that you make from that instructions or from that definition. So yeah. So yeah, very loose analogy, how that translates into code. So similar to how with functions, we both define a function and then call the function to say, here's my shortcut, or here's a bit of code that I'm going to call later when you want me to use it. Defining and instantiating, defining class and creating an object, or instantiating an object from the class, kind of follows the same pattern of you create the instruction somewhere, you let the computer store that, and then later on you call on that set of instructions to create an object. So similar to create a function, say I want to use it later, you kind of create the definition of this is my class for creating an object, and then you call, you use it later to create the actual object itself. And so when you're designing a class, because it's going to be a more complex thing, you kind of have to think about sort of what that object needs to look like or what that object needs to hold. So sometimes starting off with a simple question of, does it make sense to use an object? If you're just storing a simple thing like a single number, you don't need an object for it. That's overkill. You can represent it as an int or a float. But if you do have a more complex use case, say like you're trying to represent, a vehicle which has a bunch of different attributes, which aren't just single numbers. Like if you try to say like that car is like a 1, like that's not very informative. Those are situations when you'd want to use objects and create a class to define those objects. And so you'll need to consider sort of what attributes and methods that class definition or that set of instructions like requires. And so attributes are those characteristics or basically variables that every object will have and store values in. And then methods are functions or built-in capabilities that every object has kind of built in right off the bat. By definition, when you create a class and you name it, it's named in this convention upper camel case. So you start with the uppercase letter at the start of every word. So instead of putting spaces in between multiple words, you just start with an uppercase, everything's lowercase. At the start of the next word, uppercase, lowercase, and so on and so forth. So classes are defined globally. So same as functions, aligned all the way to the far left of your screen. No indenting. And so what this does, also outside separate of any of main or any functions. So you're not defining a class inside the function. The class should be basically at the same left indent level as a function, because by doing so, you can kind of, again, following that pattern of here's some code that I'm going to use later. By doing that, you can kind of let other parts of the code use that class definition. And so it needs to be all the way to the left. It's not in a block. It's all the way to the left in your file. So how do you start defining a class? How do you start saying like, this is my chunk of code that's going to be instructions to create an object? So you start off with the syntax. So similar to function, except instead of def, you put the word class. Then you have, so this says, I'm going to create a class, or I'm going to start writing those directions and instructions on how to define my object. Then you have class name, which is, this is what I'm going to name, or this is what I'm creating instructions for. And then parentheses, and then you put the word object in the middle. This part is convention, close parentheses, and then colon. And then, so again, similar to functions, this is going to be indented all the way over to the left at the start. So this is the start of the definition. And then underneath there, you're going to indent over and then write a block of code that's indented over. Again, because this is Python, indents matter. So you have to indent underneath that main class definition part, so that you can say like, hey, this block of code is going to be my set of directions for how to create this object. Similar to the function being similar to how functions have a block of code underneath them to say like, this block of code is attached to this function with this name. Classes are basically, here's some code to create an object that's attached to the directions that are named this. So similar concept. Again, make sure that it's indented all the way to the left. So good luck with more terrible drawing. Basically, the class definition is going to be the same indent over as the function definition, and then the code that belongs in that class definition is indented a little bit over the same way that the code under function is indented all the way over. So just for more clarity. So, all right. So creating an instance of an object from a class. So by creating class definition, you're saying, okay, eventually I will have, or can create objects that have these certain characteristics and these behaviors. But just by having a set of instructions doesn't mean you can actually create something. Like I can start a cook, like I like cooking. So I can start a cookbook, but I'm not gonna get cookies until I actually follow the instructions and make the cookies. So defining the blueprint or defining the class definition to say like, this is what the object looks like, that's only part one of creating your objects. Part two is now you have to use that blueprint to actually create the objects themselves. And so this behavior is also called instantiating. So whether you're creating / instantiating, that's what's going to actually give you actual objects. And so the syntax for that is going to be pretty much to say, to create your objects off the bat is going to be variable name equals class name, and then open parentheses, close parentheses. And so the syntax of that basically being that I'm going to have some variable that's going to represent or hold some object that I'm creating with a blueprint named this. So kind of similar to how we have variables, we can say variable equals function name, open parentheses, close parentheses. It's a similar concept to saying like variable is going to equal some object that I created with the instructions in here. So again, same thing as functions, basically variable name equals thing that you produce. So kind of like a basics, before we get into the actual like defining a class, kind of the basics of what those two parts look like is here's your class definition of here's a class called vehicle, here's a set of instructions on how to create a vehicle, and then a block of code which is going to determine how we create that vehicle or what attributes and what behaviors it has. And then also down here is where we actually say hunt for these instructions on how to create a vehicle, give me an object that is a vehicle, and store it as this variable. So those are the two parts, defining a class to say here's how I make an object, and then actually instantiating an object from that class definition by saying this variable is going to have or is going to be an object of this type that I created using the instructions from up here. And so delving into sort of that class definition, so the two parts of that are attributes and methods. So attributes are variables that we're going to store inside of an object. How we actually say what attributes an object is going to have is we can use a constructor to define what attributes we want to create an object with. To say, when I create this object, by the time I finish creating this object, is going to have these particular characteristics, it's going to have these particular types of values. And so a constructor is a very specific method. We'll get to that in a short while. That sort of lays out, these are the values that I want any object of this type to hold. And so the syntax for defining a constructor or creating a constructor is def. So stepping back a bit, a constructor is a method, and a method is a function which is part of a class. And so because a constructor is a method and a method is a function, a constructor is really just an extra special function. And so the way that you define a constructor is the same way that you define, it's kind of like the same way you define a function, like a normal function. So you start off with def, but this part is very, very special, is the name of your constructor. This is the only thing you can name your constructor. It's an underscore, the word init, INIT, then you have underscore, underscore. So you have to name your constructor this, because it's kind of like a keyword in Python to say this is the method that's going to define what attributes an object will have. So if you don't do 2 underscores, if you just do a single underscore, you don't put the word in it, you don't finish off the 2 underscores. Basically, if you mess up any part of this, Python will not recognize that this is a constructor. And so it won't treat it as that special method that creates an object. So you will be screwed. So make sure, especially with the double underscores, because when you type it out in PyCharm or in Rebel, sometimes it can just kind of like all blend into one line. Make sure you have 2 underscores on both sides. It absolutely matters. But once you get done with that, then you open parentheses, then you have the word self, which we will explain later, close parentheses, colon. So pretty much the same thing as any normal function definition, just the main like key points being it must be called this, and you must also put the word self in there. So these are, again, those special methods or functions that define here is what attributes I want my object to have. They do not have a return value, so you don't like return a thing. You just kind of do sort of those like side effect behaviors that live on in the function. So no returning of anything, but they are automatically called whenever you want to create an object. So pretty much if we go back up to here where we're saying car1 is going to equal vehicle. So what this is saying go up to the set of instructions called vehicle, hunt for some function or some method that looks like this, and then run whatever code is part of this particular method. So that's kind of how it works under the covers. And that's why you really need to write it exactly like this, because otherwise Python will not know how to find this very, very special method. So, so sometimes you can, so this is the basics of it, but like all other functions, sometimes you can pass in extra values if you want to use specific values when you create your object or when you're in this function. So something like this, where you have the def and then the underscore init underscore, I swear that's 2 underscores. My highlighting is jumping. Open parentheses, self, and then, so that's like what we've seen so far. Then it kind of starts to look like all the other functions that we defined so far with multiple arguments or multiple values. So then you have comma, make param, comma, model param, close parentheses, colon. And so what that's saying is basically when I create a vehicle, I need to know it's some parameter that is going to be the value of its make. So what kind of car it is. And then the model, which is another part of what kind of car it is. So it's saying you can create a vehicle. You can use my instructions to create a vehicle, but I need to know these 2 values in order to create my vehicle properly. And so pretty much once you define that very special init function or that init method and say, as part of the definition, I need this value and I need this value, in the code within that method, you'll see it's indented over. You can use those values to set up specific variables. So in this case, what this code is doing here is saying self.make. So self.make, self dot is kind of how you say this is an attribute that's going to belong to the object that this class is defining. So in this case, it's saying when you create a vehicle object, self.make, make is going to be one of the attributes of the vehicle. Model is going to be one of the attributes of the vehicle. MPG is going to be one of the attributes of the vehicle. So you can see this example. We're saying the make attribute is going to hold whatever value of make param that was used to create the vehicle. Model is going to hold whatever value that model param, whatever model param value was used to create the vehicle. And then you have this last one, which is MPG equals 0. So you'll notice that even though we're setting up 3 different variables over here, The self part basically means that this is a variable that belongs to an object. So it's basically make, model, MPG. Even though we're setting up 3 variables to be part of this class, so we're saying that every time we create a vehicle object, they will have this attribute, and this attribute. We're only taking in 2 values, so a make value and a model value. So we're only saying, like, when I create my object, I need these 2 values. We're not saying I need 3 values, I need 2 values. That's okay. You don't have to pass in a value for every attribute you want to use. So we're using make, model, and then for MPG, we're saying just straight off, every time we create a vehicle, it's always going to start at 0. And so that's perfectly fine to sort of like hard code or initialize your vehicle with sort of like a dummy value, because we can always calculate and update that later. But that is perfectly valid. And so kind of finishing out, since we defined this is how I'm going to create my class, we started off with that. So by creating this particular constructor method of definite yada, 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 and then within that setting up these 3 attributes, we've created sort of the start of here's how I'm going to create an object. And so down here, when we create the object now, we're saying, hey, go find the instructions named vehicle and create me a vehicle object, create me an object that's going to represent a vehicle using these 2 values over here. So we have a Ford and we have a Fiesta. And so same thing with regular functions. These values are going to go and be represented by whatever values that you defined as part of your constructor, or that very specific, again, that very specific function definition. So you have Ford is going to be used as the make param. And then you have Fiesta, which is going to be used as the model param. So what you're saying when you're saying create me a vehicle from Ford and Fiesta, these 2 values are going to be used thanks to the power of this class definition up here with this very special init value over here. We're going to create a vehicle or an object that's going to represent a vehicle, and that is what is going to be represented by the variable car1. And so yada, yada, yada. Also, like functions, ordering does matter. So the first one is going to be make. The second one's going to be model. Ignore the self for now. We will get into that later. Or I suppose we can get into it now. So the idea of self, this video is going to run a little long and I apologize. So the idea of self is sort of a way for Python to give an object the knowledge of you can access your own attributes. It's kind of like it sounds like a silly concept, but it's actually super powerful. And so because every object that you create from a single class definition, so we have our vehicle class up here. So this is one class, one definition, 1 set of instructions on how to make a vehicle. But again, that concept of how we can use it to create multiple vehicles. So we have car1 down here. Apologies. And then we also have car2 down here. So these are 2 separate objects, 2 separate variables. Car1 is completely different from car2, but they're both using the same set of instructions of vehicle and vehicle. Because they're creating the same type of object, they're holding the same types of values. And so not every vehicle you create is necessarily going to be the same. Like in the example we have here, there's one vehicle that's going to represent a Ford Fiesta. There's one vehicle that's going to represent a Honda Accord. Those are 2 very different cars, very different vehicles. And so not every vehicle object is going to hold the same values for every attribute. It'll have the same attributes. So every car will have a make and a model and MPG, but one car can have a make that's a Ford, one car can have a make that's a Honda. And so we need to provide, when we create these objects, we need to provide a way to for every individual object, so every individual car in this case, to be able to know what specific type it is. So the Ford vehicle should know that it's a Ford, the Honda vehicle should know that it's a Honda. And so that's what self allows us to do. Self says, like, after you are created, you know the values of your own attributes. You know your own characteristics, you know your own values. It's kind of like, as a person, you know your own name. Everybody has a name, but you know your name. You don't necessarily know other people's names. Like if you're going to a grocery store and you see a random stranger, you don't necessarily know their name. They have a name, but you don't necessarily know it. And could be the same, could be different from yours. And so self represents that concept of you know your own self, you know your own name. And also other characteristics, like you know your own height, you know where you live. You don't know where a stranger checking out in the grocery line lives necessarily, but they live somewhere, and they have a name. And so it's kind of that concept of, even though everybody has the same attributes and characteristics, you can only access, or you only know for sure yours. And so that's why we have that built-in word self over here, because it's saying like, you know your own self, you know your own make, your own model, your own MPG, you don't know anybody else's. So that's where that gets built in. And so the self is really just saying, you are setting this attribute for yourself. You're setting this attribute for yourself. You're not setting it for other people. Like you're not saying, you're not going around naming other people. You're just being like, this is my name. So by saying self.mpg, you're saying set the MPG for myself. And so that'll be the same concept when you access the value of variable to say like get the model of a specific car, get the model of your car. You can only get that particular car's model. And so, yeah, that's kind of the essence behind self. And so putting it all together, yeah, I think that's kind of an overview. I will break off sort of the methods part into a separate video, but that's kind of the start of here's how you start creating a class and objects from that class.